Hey everyone, welcome to this session on system design. Whether you are preparing for a system design interview or working on a real world application, you will face several challenges while designing scalable, reliable, and efficient system. In this video, I will walk you through 10 of the most common system design problems and how to solve them. Let's get started. First problem, and probably the most common problem in the system design is scalability. Many systems work fine when traffic is low, but start failing when user is increased. So how to fix this issue? The quick solution is use horizontal scaling instead of just vertical scaling. Use load balancers like AWS ELV, Nginx to distribute your traffic evenly. Use cache frequently to access your data, like Redis or Memcache. I can share a real world example like Twitter scaling challenge. When Twitter first launched, it experienced frequent outages due to monolith architecture and then couldn't handle this increasing user traffic. The companies they solved by transitioning to microservice architecture and implementing caching at different levels. They also introduce sharded databases to handle millions of tweets per second. In one of my next video, I'll definitely touch base this system design problem for Twitter. Here, let's focus on the second problem related to system design. Single point of failure, SPOF. Many systems rely on a single server, database, or components. If that fail, the entire system goes down. This is called a system design single point of failure problem. But how to solve it? Implement redundancy. Have multiple instances for your critical services. Use database replication like primary, master slave. Introduce failover mechanism. So if one service fail, another service will take over. I hope you understand single point of failure and how can we handle this issue. Let's move to the third problem, latency. Yes, friends, latency issues are very frustrating. If your system take more than a few seconds to respond, user will definitely leave. Like you or me, if we are looking this video or probably looking a video on a Netflix, and that video is keep buffering. So what will happen? We'll definitely drop or retry or refresh, and chances that user will drop off from there. So this is a very important thing. How to solve it? Use CDN to static to serve the static content faster. Optimize database queries with indexing, with sharding, and other techniques. Use asynchronous processing, especially with message queue, Kafka, RabbitMQ. There are a number of different solutions available in our cloud architecture. So always try to use them to deliver fast. Let's move to the fourth problem, data consistency versus availability. A very well known theorem, CAP theorem. If distributed system, you often have to choose between strong consistency versus high availability. The CAP theorem states that you can only have two of the three: consistency, availability, and partition tolerance. So choose which two you want for your system as per your use case. What is the solution of it? For banking application, prefer strong consistency, asset transactions. For social media feeds, eventual consistency is also fine, like NoSQL databases. Choose databases accordingly. SQL for consistency, means the relational database, and NoSQL for availability. Okay, let's move to the next problem, insufficient data storage and management. Bad database design leads to slow queries, increased storage cost, and poor performance. So, what we can do to avoid this? Normalize for reducing redundancy. We have gone through 3NF, BCNF kind of normalizations. Use them properly. Denormalize for read heavy applications. Optimize your queries for read heavy applications as per the need. Use NoSQL database for scalability when needed, like MongoDB, DynamoDB. There are a number of solutions available for that. The next is poor caching strategy. Caching speeds up your system, but the bad caching strategy can lead to stale data or unnecessary cache eviction. So there is a hit and miss policy on caching. You can just go through that. You will get to know how a poor caching strategy or a good caching strategy can lead to a pros or cons for the overall system architecture performance. Use cache invalidation technique properly, like time to live, LRU, least recent used. There are a number of strategies how we can invalidate the data which is stored in cache. That is very critical for a cache. Store session data in Redis instead of database. Implement caching at multiple levels, like browser cache, then CDN, then application layer cache. So from where you are getting the data, just always try to get the data faster. So always try to store your data as near as possible to your end user. The next problem is if we are on a microservice architecture or there are n number of complex services or multiple services involved, lack of monitoring and observability will tends to making so many problems in debugging. If you can't monitor your system, you can't fix it when things go wrong. So use centralized logging like ELK stack, Elastic, Logstash, Kibana. Set up real-time monitoring like Prometheus, Grafana. Implement tracing for distributed systems. There are a number of solutions available for this, like OpenTelemetry. Cool. So we have discussed around seven problems, seven generic things which we should know or we should cater while designing a system, while designing a robust system. So moving to the next problem, which is very important, related to security of our data and in current digital era where everything at stake if it's unsecure. Security vulnerabilities. Security breaches can lead to data leak, financial loss, and reputation damage also. So always use authentication mechanism like OAuth, JWT, which is a basic need. Encrypt the sensitive data. Follow the principle of least privilege. Don't give access to everyone of your data. So everything is not available for everyone. There has to be a role-based access control. Great. Let's move to the next problem, which is traffic spike and load management. Yes, everyone wants to do the business. As and when we started, the traffic was low. As and when business grows, the traffic sharply moves and traffic spike can overwhelm your system and leading to downtime. Use auto scaling. We have AWS auto scaling, Kubernetes, all the schemes available already. Implement rate limiting. So API gateway throttling is very important for that. To avoid the attacks like DDoS attack is there, then if we have rate limiting or circuit breaker, we will avoid the repercussions of it. Queue request using message broker like Kafka or RabbitMQ. So if you have to process n number of events, there are multiple events, the millions of billions of events are there. If you have to process the big data, the huge number of requests are there. How to process those requests? You can just queue up, implement asynchronous architecture to grab the event, process it, and then give the result accordingly. I can just share a real world example like Black Friday sales are there, e-commerce website usually every year during Black Friday. Websites like Amazon, Flipkart, and Walmart see extreme surge in traffic. To handle this, they use auto scaling services, edge caching, and queuing system to process orders smoothly without downtime. So this is very important for a highly scalable system and to handle the peak traffic because we are architecting the overall system for a normal day traffic. But at a particular day, that traffic can multifold to 1,000 times and more than that. So we can't afford every second day we have that amount of infrastructure available with us because there is no need. So we need auto scaling kind of a thing here. And the last, not the least, inefficient communication between services. If we are on a microservice architecture, see there are pros as well as cons of the microservice architecture. So microservices rely on communication, but synchronous call can slow everything down. So use asynchronous messaging using Kafka or RabbitMQ. Implement API gateway for service to service communication. Consider GraphQL to reduce multiple API calls. So these are the small little steps which we can take to avoid the insufficient communication between services and to avoid the overall latency created by the problem in one service and it will be replicated to the other services just because the dependency. Okay, so we covered the 10 common system design problem and how to solve them, right? Remember, system design is all about trade-offs. There is no one size fits all solution. If you like this video, please always remember to subscribe and please comment which is the problem which you face the most till now in your career. That will make me, you can say, a lead to deep dive on the next video on a particular area. And for the ease of my end users, I just consolidated what all things we discussed in last 10 to 15 minutes, all the 10 problems at one place and how we can avoid those problems. Thank you, friends. Once again, if you like the video, don't forget to like it and subscribe it. Bye bye.